Okay, Math 10s, we are going to continue our study on radicals, and we're going to be moving to lesson number 6. I will do this lesson in 2 parts. So I'll do the first part, give you your homework. Once you've practiced that, are comfortable with that, then you could watch your second part and do the second bit of homework. Okay, so to start, it's going to be a little bit of a review from the last lesson. And the last lesson I introduced, remember what a radical was. So a radical is just like the mathematical term for square root symbol. And then in the lesson, I talked about how some properties of radicals are that if the index is the same, so this index is invisible to and that's a 2, what we could do if they're being multiplied, the two radicals, we could multiply the radicands underneath. So root a times root b is the same thing as root ab. As well, we can do that with division. If we're dividing two radicals, root a over root b is the same thing as the square root of a over b. Okay? What we're going to do in today's lesson, though, is we're going to be given radicals and we're going to be simplifying radicals. And I'm going to show you sort of two different strategies. Okay, so class example number 1 says, write the following as a product or quotient of radicals. So just remember that product, if you see the word product, that means multiply. If you see the word quotient, that's division. Maybe you want to jot down sum is addition. So if you see the sum of two radicals in grade 11, that's going to be the addition of two radicals. Or if you see the word difference, that's subtraction. Okay, so they want this expressed as the product of two radicals because they're giving me a multiplication here. So 4 times what would give me 24? So 4 times 6 would give me 24. And you know that what I could do is these two can be written as two separate radicals, right? So that could be written as root 4 times root 6. And the reason is, remember, 4 times 6 is 24. So if all I've done is I've taken root 24 and I've written it as a product of two radicals. Then from here, what you could do is one of these two we could evaluate. One of these two you should be able to do in your head. What's the square root of 4? The square root of 4 is 2 times this guy we can't evaluate. We'd get a decimal. So the answer is 2 root 6. And you could check this on your calculator. So I want you to type in the square root of 24 and 2 root 6. Let's see if you get the same answer. So square root of 24 and 2 root 6, and we get an identical answer. So I said that this is equivalent to this. It means it's equal. That's true if your answers are identical. Okay, let's try that over here with B. So they're saying root 18 is the same thing as 9 times what? So we know that to get 18, it would be 9 times 2, right? Then we could say, okay, well, that's the same thing as root 9 times root 2. Everybody should agree with that. And if you check 9 times 2, that gives you your radicand of 18. Now look at these two numbers. Which one can you take the square root of? The square root of 9 is 3. Root 2 is my answer. And we'll check. Let's check if we're right. Square root of 18. And I'm saying that's the same thing as 3 root 2. And it is. Okay, let's do the division of two radicals. We know that the square root of 11 over 4 from our last lesson could be rewritten as root 11 over root 4. Then ask yourself, can I evaluate either of these? Well, we know that the square root of 4 is 2, so that would be root 11 over 2. That's one way you could write the answer. The other way that you could write this answer that I just want you to see, because sometimes your textbook will do this or your workbook. If I said to you, okay, what's the invisible number in front of this radical sign? So some students will say, oh, it's a 2. And I would say, no, 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 that's the index, right? But I could put an invisible, like what's an invisible number I could multiply that root 11 by? And the answer is 1. There's an invisible 1 there. Okay, so another way that students might that you might see this written is this is really 1/2 times root 11. So another way that you could see that is 1/2 times root 11. So I could write that as an answer, and I don't need the invisible one if I'm going to write it like this, or I could write it like this. What I want you to do, just to see if you understand this, I want you to actually do number 4 in the homework. That's going to be one of the first questions I'm going to assign to you. So let's just look for number 4. So it says convert the following radicals. So again, you would say, okay, these are all division. This would be square root of 2 over square root of 9. Square root of 9 is the same thing as 3. So that's the square root of 2 over 3. And then you could write it like that. Or some students will say, can I do this as my answer? 1/3 root 2, and I would say yes. You could do either or. Okay. This one here, root 5 over root 4, that is equal to root 5 over 2, right? And again, you could say that as your answer, or you could say, okay, Mrs. King, I want to write that as 1/2 times the square root of 5. You could do either. This guy here, root 18 over root 25. Okay, so a couple of things. This is root 18 over root 25. We know that root 25 is 5. So that's root 18 over, sorry, that would be root 18 over 5. Now, this answer is not actually done. And the reason why it's not done is you always have to look at your radicand and you always have to say, well, are there two numbers that I could multiply 18 by? And in this case, we could have said, okay, 18 is the square root, is the same thing as the square root of root 9 times root 2 all over 5. And root 9 times root 2, well, what's that? Root 9 is 3 root 2 over 5. Okay, so C and D are a little bit trickier. Let's look at D. I think the same thing happens with D. Let's check. Okay, so what this is 7 times the square root of 20 over the square root of 49, right? That would be 7 times the square root of 20 over square root of 49 is 7. Okay, so that's kind of interesting. We know that 7 over 7 are going to cancel, right? 7 over 7 will cancel. That will give us a 1. But then you have to look at that root 20, and you have to say, okay, are there numbers that I could multiply root 20 by? So like it could be 10 times 2, 4 times 5. And can you take the square root of one of those numbers? So root 20, we could do a couple of things. We could say root 20 is the same thing as root 4 times root 5. Root 4 is 2. And the square root of 5, I can't simplify that. So that would actually be my answer. I'm going to show you in a bit another method that we could do, but this is just one method that the book likes to show you. Okay, let's go back to the first page. So let's go back to page 39. And we're going to skip this. And we're going to actually go to this, sorry, to page 40. And I'm going to teach you the difference between an entire radical and a mixed radical. And then I'll show you another strategy that you'll use almost all the time to simplify radicals. Okay, so there's two different types of radicals. Radicals are classified as being either entire radicals or mixed radicals. So I'm going to give you examples of entire radicals. Entire radicals would be like the square root of 49 or the third root of, let's say, 75, or the fourth root of 218. These are entire radicals, and the reason is the number, invisible number, in front of each of these radicals, if I said, okay, what's the invisible number that I could multiply each of these radicals by? What would it be? And that answer is 1. There's an invisible 1 in front of all of these. If you get to a point where you have like an invisible 1 in front of your radical, that is what's called an entire radical. A mixed radical, on the other hand, will be something like the square root of 36, and then I put a number in front of it other than a 1. That becomes a mixed radical. Or I could take, let's say, the third root of 10, and I'm going to put any number in front of it other than a 1. This would be a mixed radical, and this would be a mixed radical. And what we're going to do in this lesson is we're going to convert between entire radicals and mixed radicals, okay? Now, the book has one way that they like showing how to do this converting between entire radicals to mixed radicals. I like using prime factorization. So what we did in the first few lessons, because I find when students do prime factorization, they will never get these questions wrong. So prime factorization, remember, is we're dividing by prime numbers, 2, 3, 5, 7, 11, 13. So you're going to get a number, and they give us a square root of 108. So first of all, if I said, is that entire or mixed? You would look at this and you'd say, okay, what's the number in front of here? It's a 1. This is an entire radical. Square root of 108 is entire radical. What we're going to do is we're going to rewrite 108 as a mixed radical. So how we do that is let's divide it by its primes. The lowest prime is 2. So take out your calculators, type in 108, divide that guy by 2, and you get 54. 54 divided by 2 is 27. So 2 and 54, 2 and 27. Now 2 is used up. Let's divide 27 by 3, and we're going to get 9. 9 divided by 3 is 3, and we would stop. Circle all of your prime factors, and now we're going to say, okay, the square root of 108 is equal to the square root of, and let's rewrite this as a product of the primes, 2 times 2 times 3 times 3 times 3. 2 times 2 times 3 times 3 times 3. Okay? Now, what do we do with this? I tell my students, once you get to this stage, write in that invisible index. Okay, so the invisible index in a square root is 2. What that 2 tells you is to circle any pairs underneath your radical sign. Any pairs that you see, go ahead and circle them. I've got a pair of 2s and a pair of 3s. For every pair you circle, you're going to cross out that pair, and you always take out one number. From this pair of 3s, I'm going to cross out that pair, and I'm going to take out 1 3. And what I have left over must stay under the radical sign, and that's a 3. Then you say to yourself, okay, what is 2 times 3? 2 times 3 is 6 root 3. So what I'm going to argue, and we're going to check on our calculators, is that root 108 is the exact same thing as 6 root 3, that the answer to this is 6 root 3. Let's check on our calculators. So on our calculators, the square root of 108 is identical or equivalent to 6 root 3, and you did it right. Okay? Now, some students will say to me, okay, so Mrs. King, why when you circle your pairs, why do you cross them both out and only take out one? So this is my answer. I would say to you, what's 2 times 2? And you'd say 4. And then I'd say, okay, well, what's the square root of 4? The square root of 4 is 2, right? Over here, 3 times 3, what's 3 times 3? That's 9. What's the square root of 9? 3. So for every pair you circle, you only ever take out one of those radicals, okay? Let's see if this makes sense. So let's do these questions. 2, 3, 5, 7. So write your primes, 11, 13. 50 is the same thing as 2 and 25, 5 and 5, right? That's how I'd break down 50. This square root of 50 is equal to the square root of 2 times 5 times 5. And you circle, or actually let's put our invisible index in first, which is a 2. Circle all your pairs. For every pairs, you cross it out, both numbers, and only one of them ever comes out. But they both get crossed out. What's remaining stays under my radical sign. So the square root of 50 is equivalent or is equal to 5 root 2. Okay, so the square root of 50 is equal to 5 root 2. So let's check if we did this right. Square root of 50, 5, square root 2. And we did it correctly. Let's do this one, 45. We can't divide 45 by 2. Let's divide it by 3. So 45 divided by 3, you'll get, okay, so 45 divided by 3 is 15. 15, we could still use our 3. Yeah, 15 divided by 3 is 5. I'm done because that's a prime number. So the square root of 45 is equal to the square root of, let's write 45 as a product of its primes, 3 times 3 times 5. Put your little invisible index in. That tells you to circle pairs. For every pair, cross it out. One number comes out, and what's left under your radical sign becomes your radicand. So the square root of 45 is equal to 3 root 5. Is equal to 3 root 5. So let's check on our calculator. Square root of 45 is equal or equivalent to 3 root 5. One of the reasons why students actually tend to do really well in this unit is because if I gave a quiz on this, you can check your answers by typing it on your calculator, and you'll know if you're right or wrong before you even hand in your quiz, right? Students who actually take the time to type it in, those students, they tend to do exceptionally well in this unit. Now, some students, before I do C with you, some students will say to me, Mrs. King, okay, I do like this method and I see where you're going. Could I have not done this? Could I have not done what you showed me in class example 1 and said, well, square root of 50 is the same thing as the square root of 25 times 2. And then square root of 25 is 5 root 2. Could I not have done that? You might have said. And the answer is yes. That's a method you could do. That's a method that your workbook teaches you. But why I don't necessarily, I need you to know that method, but why I don't necessarily like it is because if I give you a number like 320, it's hard to visualize this and say, okay, well, what are the numbers that multiply to 320, right? And one of them can be square rooted. So I always tell my students to do this method because then they will never get it wrong, right? So let's do 320 quickly, right? Like if I look at that and I say, okay, what are the two numbers that multiply by 320 and one of them I could take the square root of? It's difficult to do. Or I could just quickly do this. 320 divided by 2 is 160. 160 divided by 2 is 80. 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. So look how fast I did that. Square root of 320 is the exact same thing as the square root of 1, 2, 3, 4, 5, 6 twos. 4, 5, 6 twos, and 1 5. Don't forget that guy. Okay, put your invisible index in. The index tells you to circle pairs. Pair, pair, pair. For every pair you see, cross out both numbers and you only ever take out one. Cross out both numbers and you only ever take out one. Cross out both numbers and you only ever take out one. What's remaining has to stay as my radicand. So that would be 5. and then say to yourself, okay, what's 2 times 2 times 2? So 2 times 2 is 4, 4 times 2 is 8, so that is 8 root 5 is your answer. So let's confirm. Um, root 320 is the same thing as 8 root 5. Root 320 is the same thing as 8 root 5. Okay. For those of you that are still like, okay, I kind of like this method a little better, what you would have had to see if you like this method is you would have had to see that this, and this is where students have a harder time, this 320 can be broken down to root 64 times root 5. Oops, root 64 times root 5, because 64 times 5 is 320, right? So you'd have had to see that those were the two numbers that multiply to root 20, and then the square root of 64 is 8 root 5, right? And many students, it's just they have a harder time seeing that. Okay, let's do this last example, and then I'm going to give you your homework, and I'm actually going to go to one of the previous ones we did for homework, and I'm going to show you how to do it the nice easy way now. Okay, convert the following radicals to mixed radicals in simplest form. So what's happening with these three is they look like they're mixed radicals because there's a number other than 1 in front of it, but they're actually not in simplest form. So basically I could break down the square root of 192. So let's do the method that if you guys do this method, you'll always get these questions right. Okay, so prime numbers, 2, 3, 5, 7, 11, 13, 17, 19. We are only breaking down this 192. I'll show you what we do with this 2 at the end, okay? So let's break down 192. So I'll do it for you quickly. If we divide 192 by 2, you get 96. Divide 96 by 2, and you get 48. 48 by 2 is 24. 24 by 2 is 12. 12 by 2 is 6. 6 by 2 is 3. Okay? So now I'm going to rewrite this. 2 root 192. And again, I'm going to show you what to do with this. That is the same thing as 2 times, we broke down our 192. So 1, 2, 3, 4, 5, 6 twos, 3, 4, 5, 6 twos, and a 3. Again, don't ever forget that guy. Okay, so let's do what we do. We put our invisible index in. That index tells you to circle your pairs. Pair, pair, pair. For every pair, cross it out, take out 1, 2. Cross it out, take out a 2. Cross it out, take out a 2. What's remaining, that's my new radicand, is 3. Now, before I do this, you can't forget this guy, right? So that 2 just needs to be brought down. If there's a number already out front, don't forget that guy. That guy gets brought down. So these 3 2's were from inside the radical, right? Because the square root of 4 is 2, square root of 4 is 2, square root of 4 is 2. Then I need to bring that guy down. So now my answer is 2 times 2 times 2 times 2. On my calculator, I'm just going to type in 2 to the power of 4 to get it quicker. So 16 root 3. My answer, I'm going to argue, is 16 root 3. Let's check because I want to get 100% on this test. So 2 root 192 times 16 root 3. 2 root 192 is equivalent to 16 root 3. Yes. Okay, you have just simplified. This radical was not simplified. The simplified radical would be this guy here, which is 16 root 3. Okay, I'm going to erase this, so make sure you've got this down, and we're going to break down 160. So 160, again, ignore that 3/4 for now. 2 and 80, 2 and 40, 2 and 20, 2 and 10, 2 and 5. So that is the same thing as 3/4 times 1, 2, 3, 4, 5 twos, and a 5. Okay, I'm putting my index in, and I'm going to circle my pairs. That's all I have. Oh, I like this question because we haven't done one like this yet. Okay, for every pair, what do you get to take out? You get to take out a 2. Cross out those guys. Take out a 2. What's remaining, because that can't come out, must stay under my radical sign. But what is 2 times 5? 2 times 5 is 10, right? We can't simplify 10. We can't break that down and simplify that. And then don't forget this, 3/4 in a bracket. So let's type in 3/4 times 2 times 2. Open bracket, 3/4 times 2 times 2, and that gives me 3√10. I always like checking, so I'm going to type in 3/4 in a bracket √160. Open bracket, 3 divided by 4. Close that bracket, square root of 160. And I say that that is equivalent to 3√10. That guy simplified, whoops, 3√10. I did it correct. Okay, this one should be nice and simple. Let's do this one quickly. This is the same thing as the square root of 7 over the square root of 9. Now, you know that the square root of 9 is 3, but if we were actually breaking it down, right, so that's 3 times 3, so that's √7 over the square root of 3 times 3. For every single pair that you circle, you always take out one of those numbers. And if I don't have anything left under the radical sign disappears, right? So this would be √7 over square root of 9 is 3. Okay, let's circle the homework, and then I'm going to show you one more thing from question number 4 that we've already done. So let's get this homework circled. Okay, so I want you to do number 1. You're just identifying if each is an entire radical or a mixed. So remember, this guy has a 1 in front, it's entire. This guy's a mixture of a number other than 1, so it's a mixed. Convert the following mixed radicals in simplest form. For number 2, I want you to do actually for number 2, I want you to do them all. And again, you could do, if you really want, √4 times √2, which is 2√2. Though, if I were doing this, for every single question, I'd be doing it this way. 8 broken down is 2 and 4, 4 is 2 and 2. √8 is the same thing as 2 times 2 times 2. Put your index in, circle your pairs. For every pair, cross it out, take out 1, and then this stays underneath your radical sign. So that's how I would do this question. I'd break it down, right? 75 divided by 3 and 25, 5 and 5. 98 divided by 2, right? This guy divided by 2. So do the method that I just taught you for all of number 2. For number 3, I want you to do A, C, F, G. Okay, I'm going to circle a few. A, B, C, D, E, F, G. I want you to do those ones. If you guys can do those, you will get all these questions right. And then for number 4, I just want to redo this one the way that I just taught you, right? So for 4D, let's redo this one because a lot of people didn't know how to break, like root 20 is confusing, right? So say to yourself, okay, this is the same thing as 7 times root 20 over root 49. We know that root 49 is 7. That's easy, right? But let's figure out what root 20 is. So root 20, 2, 10, 2, and 5. So root 20 is the same thing as 2 times 2 times 5. That would be 2 root 5, right? So root 20 is equivalent to 2 root 5. Cancel out your 7s because those 7s cancel. And then the square root of 20 is the same thing if you break it down as 2 root 5. And that concludes part A once you finish all of this homework, and make sure you check your answers.